In this video, we'll be looking at the 6 trigonometric functions that are defined by the sides of a triangle compared to the angle of a triangle. In this particular set of videos, we'll be looking at the basic 6 trig functions, that being sine, spelled S-I-N-E, cosine, spelled co with, again, the same sign. We're going to have tangent. Those are the main 3 trig functions, and then those 3 trig functions correlate to reciprocal functions, those reciprocal functions being cosecant, secant, and cotangent. So these are the 6 trig functions, and again, they are defined by an angle measure inside the function compares to the ratio of the side lengths of a triangle. The best way to fully grasp this concept is by looking at a basic 90-degree triangle. So if I'm looking at a 90-degree triangle, I have some angle theta and I have a right angle. Keep in mind that we could have put theta up here. Heck, we could put phi up here and correlate with an entirely different set of functions. Now in this triangle, we're always going to go ahead based on the angle that we've identified. We're going to consider a side that's opposite. That's this side over here. That's opposite side of that angle. We're going to consider the adjacent side as the side next to that angle. That's this one down here. And the reason why this is the adjacent side is because this side over here has to be the hypotenuse. So we have hypotenuse, we have the opposite side, and we have the adjacent side. Now again, depending on how we draw our triangle, such that it's a 90-degree triangle, and such that we label theta, we might label theta here. Now in this case, the opposite side is the one, again, across from the angle. Notice that these two sides create this angle, so this has to be the opposite side. This has to be the hypotenuse, because the hypotenuse is always directly across from the 90-degree angle, and therefore that makes this adjacent. So again, notice how the opposite and the adjacent sides can be changed depending on where we select the angle that we're referring to be. I'm going to go ahead and work with this particular example from this point forward, and in most cases I will use A for the adjacent, O for opposite, and H for hypotenuse the rest of the way through this. It's best for us to actually draw the triangle in such a way so that we're looking at it to be some form of this is theta, this is the 90-degree angle, and I'm going to go ahead and call this X, this Y, and this Z. So we might be given some of these values, we might not be given all of the values, we might be just given some of them, but in most cases the idea is, what is the sine? And sine we write S-I-N. So this is the actual word for sine. When we talk about a function, it's the sine of theta. Technically there'd be parentheses here, we don't have to put them, but that's the definition of sine. And sine by definition is the ratio of the opposite side over the hypotenuse of any triangle. So in this case, it's going to be y divided by z for this triangle, because it's the opposite side over the hypotenuse. Again, the generic sign is opposite over hypotenuse. That's your sine function. So the sine of theta is equal to that value. This will always be true no matter what triangle we're playing within, as long as it's a 90-degree triangle. So then if we look at cosine, cosine is cos, and that's going to be the adjacent over the hypotenuse, so it's x over z. If we look at tangent, tangent is actually going to be the opposite over adjacent. So in this case, it's y over x. If we look at the other functions, cosecant, secant, and cotangent, they are in some way a reciprocal. Now, a reciprocal is basically a flipped function of their corresponding function. In this case, sine goes to cosecant, cosine goes to secant, and tangent goes to cotangent. So that means that if I'm looking for the cosecant function, that's going to be the reciprocal of the sine, which means that it's the hypotenuse divided by the opposite function, or opposite side. So really, there's only technically 2 functions. Actually, there's only one, because of the way that we can talk about cofunctions, but we'll talk about cofunctions in another video. The basis understanding is that every single one of these 6 trig functions is every single possible way that your cosecant of theta is equal to z over y, your secant of theta is going to be z over x, and your cotangent of theta is going to be x over y. It's simply just the same as this function, just flipped. And this is every possible non-repeated case that you can get by picking any two values in this triangle, such that we're talking about the sides. So So those are your 6 trig functions. They're how we define them. Make note again that the reciprocal functions are just additional functions, such that cosine goes to secant, c goes to s, and s goes to c. That's the way that I'm going to help you guys remember those details, and tangent correlates to cotangent quite smoothly. Now, if we've forgotten some of the details of this, there are some nice, smooth ways to remember it. Some old hippie caught another hippie tripping on acid. That's the nice mnemonic device that I like to use. Most other students have probably heard SOHCAHTOA at least one time in their life. So SOHCAHTOA is the way that you can remember this. Again, sine opposite over hypotenuse. It's the same setup as this. Cosine is adjacent over hypotenuse. Again, I didn't write it, but it's there. Tangent opposite over adjacent is that same concept there. And then again, to find the reciprocal functions, you just have to remember which one do they correlate to. Sine goes to the cosecant, cosine goes to secant, and tangent goes to cotangent, and we just simply flip the fraction that's there. So, in the most basic form of this example, the question might be, given this particular triangle, I'm going to draw it, no, I'm not, yeah, I'm going to draw it that way. No, it's not that way. I'm going to draw it this way. We have this, this, and this. I have A, capital B, capital C. In most cases, in most of the examples, we'll see the triangle written in the form of capital letters for the angles and lowercase letters as the sides. So there's C, A is equal to 3, B is equal to 4, and they didn't give us the value of C. And the question is, find the value of the 6 trig functions. So in this case, the first thing I have to do is I actually have to evaluate what is the value of C. Well, in this case, C is nothing more than 5. And the reason why I know this is because A squared plus B squared is equal to C squared for all right triangles, assuming the form is A, B, C. Now this isn't necessarily true if I draw a triangle over here and I label this as A, this is B, and this is C. Nope, no longer true. Now it's C squared plus B squared equals to A squared. So please make sure that you don't memorize this formula in the form that it is, but in the rule that it's leg squared plus leg squared equals to hypotenuse squared, such that the legs are the 2 shorter sides of the triangle that create that 90-degree angle. So in this case, if I do 3 squared plus 4 squared equals to C squared, I can solve for C. C gives me 5 in the grand scheme of the problem. With that being found, I can now find the value of the 6 trig functions based on where theta is. And in the problem, they gave me theta to be there. So I'm looking for the sine of theta. The sine of theta is nothing more than the opposite over hypotenuse, 3 over 5. So that means that sine of theta for this triangle with this set of rules will always be a ratio of 3 over 5. That is the value of that trig function. Cosine of theta is going to be equal to 4 over 5. I look at tangent of theta. That's going to be, again, opposite over adjacent, so 3 over 4. And then to find the reciprocal functions, cosecant of theta, secant of theta, and cotangent of theta, I just simply go ahead and flip those appropriate values. Notice the sine goes to cosecant and cosine goes to secant. They reciprocate each other. So 5 over 3, 5 over 4, and then finally 4 over 3. And that's how you're going to go ahead and find those 6 trig functions given any kind of triangle. We can do this for more examples and more basic examples, but that's the meat of how do we identify or evaluate trig functions based on a triangle. This is where these trig functions come from. They come from the relationship between 2 sides of a triangle and an angle. It allows us to manipulate more appropriately and talk about how a right triangle will compare its angle measure to that of the sides of it. So if I know that I have another triangle that has the same comparison, say that I have a triangle where it is this theta, this is 8, this is 6, and this is 10, and I go ahead and I find sine of theta to be 6 over 10, giving me 3 over 5, then I know that this angle is actually the same as this angle. Because again, you can have 2 triangles where there are different sizes, but their angles are similar, or congruent is what you would call them in geometry. But this is the basic concept of trigonometric functions, how we start with them, and then we'll continue to add more information to them as we go.